Hi everyone, I hope y'all are doing well. I just want to do this video. This really covers chapter 2, levels of measurement and aggregation. Kind of a little quick PowerPoint to do with, go along with it. Um, and hopefully I can keep it under 8 minutes, but we'll see about that. I just wanted to say that it's a follow-up from last week. Everybody's doing a good job. No, I didn't do a video for chapter 1, which is really covers sampling, probability, and non-probability samples. And those things should all be reviewed for the most part within your research methods class, both at the graduate and undergraduate level, and the types of things that exist. So I'm hopefully I've been exposed to that to some degree at this point. And everybody through the discussion boards, they're fantastic in the work. So just keep it up, stay focused, and we'll keep these assignments going forward all the way through. And if y'all ever have any questions, feel free to contact me or email me. But today we're just going to briefly cover levels of measurement and aggregation, consistent with the chapter 2. So chapter 2 really it discusses variables, and hopefully y'all know what a variable is. To some degree, a variable itself it varies. So that's the underlying term right there. It varies. It's a property or a characteristic of a sample. The population takes more than one value. So things that we measure in statistics and social sciences and all sciences, we look at variables and constants. Those are the types of data we're generally inundated with. So variable can be anything from gender to age. It just depends on that type of measure. That measure changes. What that measure means, the interpretation of that measure, right? So your gender can fluctuate from male to female, or your age from 2 to 22, right? Or your household income, or your educational level, those types of things. So there's lots of variation within that. So it's pretty straightforward, and the constant itself is something that really doesn't change. It's constant. It's always consistent. Just trying to think of examples. Your textbook gives some examples about prisons, all male prisoners. That's all constant. All those folks would be constant within that type of study, because gender for everyone is male because it's in a male prison. Or um, maybe the Texas Rangers as a baseball team. That's a constant. They're always their own team, or things like that. Those things just don't change. So that's the type of measure itself. Now, moving into the 4 levels of measurement, this all should hopefully be, for the most part, review. So I'm just going to blow through it real quick. And of course, y'all can read your textbooks. And if this video isn't thorough enough, there's other resources out there on the web. People have asked me if I know any tutors and all that type of stuff, like in far places from my location. I don't really, but YouTube's got a lot of good videos, and if you type levels of measurement, there's still some conflicts there. I would suggest looking into that. Or email me and just asking me. I can help out to the best of my ability. But certainly there's 4 levels of measurement, and one of the most simplistic is a nominal measure. There's lots of good examples in your textbook. It's a variable. Attributes only the characteristics of exhaustiveness and mutual exclusiveness. So mutually exclusive, 2 events can occur at the same time, essentially. I'll give the example of tossing a coin. Once it can't both be heads or both be tails. It can't be both heads and tails on one land. It's either one or the other. So that's mutually exclusive, right? So within that, for variables, some of the most recognizable nominal variables would be religion, gender. I know that subject could change with all the politics nowadays, but historically that's been viewed as a nominal measure. Religious affiliation, Protestant, Catholic, Jewish, or Muslim, or hair color, college major. Those are things that we just place labels on. Now, within data sets, you'll see these things in there. Your text actually does a good job describing that. how some of these things will have some of these variables, like say for example gender, will have male, 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 female, 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 and sometimes we arbitrarily assign numbers to them. Those numbers don't really mean anything, they're just placeholders there, and they're good for interpretation when you're doing statistical analysis later on. So you kind of just like an index, as long as you know that they exist. It's not like you're rank ordering them. All right, you're not. If you have religious affiliation, and if you have Protestant, you give it a 1, Catholic, you give it a 2, Jewish, you give it a 3. You're not rank ordering them. You're not saying one religion is better than the next. It's just merely uh, um, a placeholder within that data set, typically. And you've got to have a code book and know what your values mean if you're going to do that within an Excel file, within a spreadsheet, or something like that. So the next level of measurement is an ordinal measure. These things can be rank ordered along some dimension, logically ordered, tend to be from lowest to highest, highest to lowest. If y'all have heard of Likert scales or Likert scales, they're generally on a 5-point scale or a 7-point scale, and everybody's probably fairly aware with these if you've taken a survey at some point in your life. But they're often used in attitudinal research, right? You're strongly disagree, disagree, neither agree nor disagree, agree, strongly agree. So you get more of a variation, and it's along a logical order. So you can rank that from lowest to highest, strongly disagree to strongly agree. So what do I think about the current political climate? I strongly disagree with it, or I strongly agree with it. Or your perceptions of how effective Burger King is at serving a Whopper. I strongly disagree with their efforts. I highly agree with it, or whatever, when it plays into it. So you kind of get variation there, and that's really one of the goals when trying to, one of the desirable goals when trying to implement some statistical analysis going forward, because you get more variation, get away from that gray yes or no. Do I like the Whopper or do I not like the Whopper? It's more of people's opinions tend to vary and exist somewhere within a no yes. Well, sometimes I do, sometimes I don't, or whatever. Do I like them in the current administration? Strongly disagree or strongly agree? Whatever. It gets more variation. It gets closer to reality, and that's sometimes a viable goal. The one thing I want y'all to know about ordinal measures, though, is that you can't assume that the distances are equal. And what I mean by that, you can't assume that the distance from strongly disagree to disagree is the same distance as strongly agree to agree. All right, I don't know if that necessarily makes sense. Just understand from now that for an ordinal measure, you can't rely on that assumption. Okay. It's not the same as going from, I'm 8 years old to 9 years old. It's the same distance from going 22 to 23 years old. So on that note, we go into a more complex level of measure. It's the interval level of measure. Whose a variable, an interval measure is a variable whose attributes are rank ordered and have equal distances. All right, and equal distances is important. The one big thing you want to remember about interval level measures, there's no true zero. Zero is arbitrarily assigned. So the example everybody tends to use often with this an interval measure is a temperature, right? So there's equal distances. 5 degrees to 10 degrees Fahrenheit is the same distance as 15 degrees to 20 degrees. That's a 5-degree temperature change, right, in Fahrenheit. But the zero, I mean, if you think of when does water freeze, in Fahrenheit it freezes at 30, and at Celsius it's at 0. There's no true zero until you use the Kelvin scale, and where there's an absence of temperature. But on those two metrics, the distances are the same, but the zero is just arbitrarily assigned. Right? So and the ratio measure is the final and the most desirable, perhaps one of the more desirables, depending on the statistical function you want to use. So I don't want to make it too crazy at this point, but ratio levels of measures are desirable because continuous measures are desirable because they have certain properties that are good with, say, an ordinary least squares type of regression model, right? And that has ideal statistical properties because we can validate it, we can test it, we can prove that type of equation. Then you get lots of variation. But a ratio measure describes a variable with all the attributes that we discussed earlier, but there is a true 0 point. There's a fixed and meaning 0 point. For example, your age. Once you're 0 years old, you're not born, you're not alive. That's it. To 22. Or money, I have, no dollar bills in my wallet at this point in time. I have $0, or in my bank account, or weight, or whatever. All these things, that 0 means actually something. And it allows for division and multiplication, since you have a meaningful 0 point. And it allows for different mathematical procedures that don't necessarily exist within the other levels of measure. So those are the four main levels of measurement in a nutshell. Now, your text kind of combines interval, they say ratio or interval level measures, and that's good. What they mean by that is that they're continuous, that they're on a continuum, so they can go infinitely. Theoretically, in theory, age can go infinitely. Nobody's going to live to be 100 billion years old, but you get the gist. It's like a line that continues on forever. All right. Now, your text kind of gets in, offers a few different little formulas, mathematical formulas. I just wanted to hit them real quick and let y'all see these things because on your quiz, on the quiz for this week, you're going to need to do a few little calculations. So you can use your calculator within the quiz. If you don't have a calculator, your phone has a calculator, you should be able to do simple division and multiplication with it. Work through some of the examples in the book and on the worksheets that you have access to. But your text also talks about descriptive statistics. I know we discussed that in chapter 1 a little bit. Obviously, you're just describing the data, describing and informing what the variable means, what it all means, essentially. So within that, rates are often combined in useful when describing data, like the NCVS, the National Crime Victimization Survey. We want to figure out homicide rates. Everybody, since all these jurisdictions from New York City to Dallas to Houston to San Antonio to Stephenville, if you look at each jurisdiction independently, everybody has a different population, obviously, and a different size police force and different size, a lot of different things going on in each of those jurisdictions, right? So the intent is to get everything on the same metric. What I mean by that, and that's where rates come into play, where you can standardize it. And then we know that 22 murders in Chicago per 100,000, or versus San Diego, where it's only 7 or whatever. I don't necessarily know any of those numbers are true, but you can see just on his face that, well, Chicago is like perhaps 3 times more deadly just based on these rates. So they're useful in that regard. So frequencies or count per some standard unit of measurement, that's what a rate is. This is its definition. Obviously your textbook has it, and here's kind of the formula, right? It's the number over the population times the standard unit. So that is subject to change, or standard unit. All these are obviously subject to change, but for example, homicides in New York, this is an example. Say there was 333 in the previous year in the population. So 333 homicides, a population of 8,405,000, and you want a rate of 100,000. So you multiply by 100,000. And here's how the math kind of breaks down. And then you can see it's 3.96 per 100,000. I don't necessarily know if that's high or low or above the national average, But when you look at official statistics and you're trying to describe that, or if you're generating reports for the agencies you work at and you want to look at rates, if you have different agencies, it's a slew of possibilities that this can be applied on. And I think you need to work through some examples and know some of that, and be aware of that formula as well. Now, proportion is a relative frequency. It's the frequency of some values relative to the total number of events. So the proportion is P. Fi is the number of cases at value I and total number of cases. So basically, if you think, I think of proportions as like a pie chart, right? So you can divide the number by the full total number of cases, and then you get that proportion, you get that slice of pie. All right, and there's obviously some examples that y'all can work through, that y'all will need to work through, especially for the quiz and for the through the worksheets and all that stuff. And percent is basically a standardized proportion. It's everything coming to the same level. Obviously, percents are what they are. It's the same equation times 100. So if I have a proportion of 0.46, that's 46%, because I multiplied it by 100. So that's pretty much all I had for this slideshow and for this chapter. Read through the chapter. The reading is still fairly easy at this point. A lot of it should be review for you guys. You know, and y'all did a great job on last week's assignments. So keep up the good work and let it go into this week. And if you got any questions, you know, feel free to let me know at any time. All right, y'all.